Welcome back, YouTube family. It's your main man, Moneybag Cool, back at you with another hot TikTok reaction video. Y'all like, subscribe, hit that notification bell so you can see more videos just like this. Let's go, baby.
Dark matter is one of the most perplexing components of our universe. It makes up approximately 27% of the universe's mass and energy, yet it remains invisible and undetectable by conventional means. Unlike normal matter, dark matter does not emit, absorb, or reflect light, making it entirely transparent to electromagnetic radiation. Its presence is inferred from its gravitational effects on visible matter, such as stars and galaxies. Astronomers observed that galaxies rotate faster than expected, suggesting an unseen mass exerting additional gravitational pull. Various theories suggest dark matter could be composed of exotic particles like WIMPs, weakly interacting massive particles, or axions. Understanding dark matter is crucial for unraveling the mysteries of the cosmos and the fundamental makeup of everything around us.
What's dark matter?
Yeah.
So it's, I mean, yeah, you know, I like these kind of questions. Those are different. Dark matter is like a mass we can't see, but we know it's there because it's got influence on gravitational pulls and, you know, the speed of gravitational orbits in every galaxies, and its, you know, its presence inside galaxies is 5 times higher than the seeable matter. So it's a huge mystery, and we can't see it, we can't observe it, but we can observe its influence. So this is dark matter, very sci-fi.
Most of the universe is made out of dark matter. Dark matter surrounds the Milky Way galaxy. If it wasn't for dark matter, the Milky Way galaxy would have spun out of control and the Earth would be flung into outer space. Can it be touched? Well, no, because it would filter right through your fingertips, right through the atoms of your body. Is it dangerous? No, because it doesn't interact with us. And then here's the big question. What is it? There's a Nobel Prize out there waiting for that person who can figure out what dark matter is.
Of course I can. It starts in the 1800s when Lord Kelvin, whose actual name was William Thomson, was trying to measure how massive the Milky Way galaxy was. And what he noticed was that it was heavier than it looked like it should be. And that started a whole bunch of scientists on this mission of measuring the mass of the Milky Way and comparing it to how much mass they could see from stars, gas, and dust. But we didn't get definitive proof that there was extra mass out there until this woman, Dr. Vera Rubin, in the 1970s started looking at what scientists call the rotation curves of galaxies. We know, thanks to Kepler and his laws of motion, that in a galaxy, the stars that are further away from the center should be moving more slowly than the stars that are closer at the center. That's because the stars closer to the center have to move really fast so they don't get sucked into the center due to gravity. So when we measure stellar speeds in the Milky Way, we should see the velocities decrease, like in this bottom line in the graph here. But Dr. Rubin measured the speeds of stars at different points in the Milky Way, and she saw that they were not getting slower. They were kind of plateauing and sometimes even getting faster. And so she saw this top line, and she was like, nah, there's extra mass out there. For the last 50 years, astronomers have observed evidence that confirms what Dr. Vera Rubin and what Lord Kelvin had thought all along, that there was extra stuff out there, and now we call it dark matter. Dr. Rubin died in 2016, but her legacy lives on in the Vera C. Rubin Observatory, and it's going to study the universe to figure out what dark matter is, how dark energy works, because that's a completely different thing, and how our universe used to behave. And it's hopefully going to start working early next year in 2025.
Dark matter is a type of matter that we can't directly detect with our current instruments. But we know it exists because of the gravitational effects it has on visible matter, like galaxies and stars. Some physicists hypothesize that dark matter might be made of particles that we haven't yet discovered, particles that don't interact with light or ordinary matter, and hence are dark. These hypothetical particles could potentially be a part of the quantum field, so, in this sense, there could be a link between the quantum field and dark matter. If dark matter particles exist, they would also be subject to quantum mechanics and would have their own associated quantum fields.
How many of you have heard of dark matter before this video, and what have you heard about dark matter? Let me know in the comment section. And I said dark matter, not antimatter. A lot of people get those confused. That's a totally different thing.
So apparently, one of the explanations for dark matter is that there's sort of an anti-universe mirroring our own that runs backwards in time. Hold on for a second. One thing that we know about the universe is that there are fundamental symmetries in nature. From snowflakes to spider webs, butterflies, you get it. We also know that in physics, things like time, charges, and parity also rely on symmetry. So what if this applied to the universe as well? And to preserve its symmetry, there would have to be a mirror image of the universe running backwards to our own. Think about it like this. The Big Bang is at the center, and you have our universe going one way, and the mirror universe going the other. Now, of course, we could never access it, but we could test it, because a mirror universe could explain dark matter, which is this invisible gravitational force that's pulling on our universe. It could explain why all of the subatomic ghost particles that we've discovered only spin in the same leftward direction, because in the mirror universe, they would have to spin to the right, which means that as time in our universe moves forward, time in the other universe moves backwards.
And if you want to hear more about antimatter, go in my video catalog and, search it up. You'll see the title whenever I was making the videos with blue and gold with the titles. You look for the one that says antimatter. You'll definitely enjoy the video. Check it out. If you're enjoying this video so far, let me know in the comment section, and don't forget to hit that like button.
Dark matter is a type of matter that we can't directly detect with our current instruments, but we know it exists because of the gravitational effects it has on visible matter, like galaxies and stars. Some physicists hypothesize that dark matter might be made of particles that we haven't yet discovered. Particles that don't interact with light or ordinary matter, and hence are dark. These hypothetical particles could potentially be a part of the quantum field, so, in this sense, there could be a link between the quantum field and dark matter. If dark matter particles exist, they would also be subject to quantum mechanics and would have their own associated quantum fields.
Very interesting.
Dark matter, a term often heard in astrophysics, refers to a mysterious and invisible substance that makes up about 27% of the universe. Unlike ordinary matter, it does not emit, absorb, or reflect light, making it undetectable by traditional telescopes. Its presence is inferred from gravitational effects on visible matter, such as stars and galaxies. The concept of dark matter emerged to explain why galaxies don't spin apart despite the insufficient visible mass to account for their gravitational pull. Scientists believe dark matter forms a vast and intricate cosmic web, providing the scaffold on which galaxies are built. Despite its elusive nature, experiments like those at the Large Hadron Collider aim to detect dark matter particles directly. Understanding dark matter is crucial for unraveling many cosmic mysteries, including galaxy formation and the overall structure of the universe. As research evolves, this enigmatic substance continues to challenge and expand our understanding of the cosmos.
Imagine interacting with dark matter, unlocking the mysteries of the universe, and harnessing its power. Sounds incredible, right? Think again. First, safety. Dark matter is mysterious and unknown. Interacting with it could have unforeseen and potentially dangerous consequences. What if it destabilizes matter as we know it? Scary, huh? Then, technology. Developing the technology to detect and interact with dark matter would be immensely complex and costly. We're talking about breakthroughs that could take decades or even centuries. What about ethical concerns? The power to manipulate dark matter could lead to immense power imbalances. Those who control it could wield unprecedented influence over the rest of humanity. An environmental impact. Interacting with dark matter could have unforeseen effects on our planet and the cosmos. We might disrupt natural balances or even trigger cosmic events. So, think about the consequences before you dream about interacting with dark matter. Safety risks, technological challenges, ethical dilemmas. Are we ready for that?
If you've ever wondered what dark matter really is, here's a diagram showing all of our current theories about what it might be. In case you can't tell just by the sheer number of different theories that we really have no idea what dark matter really is. So, since we've never directly detected it and we don't know what it is, why do we think it exists? Well, while we haven't directly detected dark matter, we've seen a lot of its effects. Our best evidence for dark matter is how stars and even some entire galaxies are moving. See, if the motion of these stars and galaxies were only due to gravitational interactions with things we've actually observed, their motion would look a lot more like this bottom curve. The issue is, they're actually moving a lot more like this top curve. Basically, they're moving at a much faster rate than we would ever expect with the things that we've observed interacting with them. This basically tells us that there's some form of mass that we're not observing causing additional gravitational interactions. This mass that we can observe is exactly what we call dark matter. And while we don't really know what dark matter is made of, we have a couple prevailing theories about what it might be. One of the most prevailing theories is that dark matter, particularly cold dark matter, is made up of what we call axions. Axions are a theorized elementary particle that are expected to be of very low mass. If axions really do exist, they would not only help us understand dark matter better, but also things like charge parity violation in QCD. Another theory as to what could make up dark matter is what we call WIMPs, or weakly interacting massive particles. WIMPs are a theorized particle that are able to interact via any force that's weaker than the weak force, but also interacts over infinite distances. Our only current example of this kind of force would be gravity, but that's not to say that there aren't others. In short, we really don't know what dark matter is, but we have a couple of pretty promising explanations for it.
Now, I'm starting to wonder, is that what dark holes, or not dark holes, black holes are made of? Dark matter. To me, it would make a little bit of sense. Is it dark matter, antimatter? What are black holes made of? Do we know? Will we ever know? And if we can know, how will we find out? Other than going inside one. Hopefully not. I don't plan on going inside one. But for y'all, for the ones who keep, they see me drinking these cups and probably wonder what am I drinking. No, it's not alcohol. It's not water. It's my fruit smoothies, man. My fruit drinks, man. My fruit juice. This one is made of watermelon, papaya seeds, pineapple, and blueberries. And yes, it does taste good. Man, it tastes amazing. And it works wonders on your body. You should try it out.
I truly can't keep up with all the science news. JWST released this photo yesterday, and at first, it looks like a regular space photo, but it's not. These 10 galaxies are connected by a 3 million light-year long filament. And the whole structure, this giant thing, is anchored by this quasar. Cosmic filaments are crazy. They're strands of dark matter and galaxies, and as they spin, they pull matter into the orbit and towards galaxy clusters at the ends. And this spinning string of dark matter connecting all of these galaxies is especially long and narrow. All of these galaxies formed when the universe was less than 1 billion years old, making this one of the earliest filamentary structures ever associated with a distant quasar. And astronomers think that eventually this will evolve into a giant cluster of galaxies. And the same project called Aspire looked at 8 supermassive black holes from the early universe and found that they were all kind of unexplainably large. And the program's principal investigator said that even if a black hole started with a mass 1,000 times greater than the sun, it would have still needed to accrete 1 million times more mass at the maximum possible rate for its entire lifetime to get this size. The moral of the story is that there's spinning dark matter connecting galaxies with supermassive black holes that are bigger than they maybe should be.
Who would have known? Let me know what you think about that clip down below so far, man. What do you think about dark matter?
Is there a multiverse? Are there other versions of you that exist? This show has me thinking about this constantly. Hear me out, because this isn't just a sci-fi idea. Some scientists are actively suggesting and working towards discovering other dimensions and universes. And if there are, how many universes are there, and what's between them, and how do I get to this one? Well, I found a new show on Apple TV Plus that explores all of this. Dark matter is based around the very cool idea of developing the ability to navigate the multiverse, and then, of course, exploring it. Unfortunately, that is one of the universes. The science in the show is based upon quantum superposition, which is basically the idea that since particles are also waves, and waves can occupy multiple places at once, so can particles. Matter. Us. Superposition has been proven to exist at small scales, and the show uses this idea at larger scales. They use this and have humans existing simultaneously in multiple universes. You also might recognize some of the cast. Amazing. So let me know, if you could travel to any universe, where would you go, and what would your nightmare and your dream universe look like? Dark Matter is streaming now on Apple TV Plus, and a new episode just came out. It is somehow crazier than the last.
If you watched it already, y'all let me know how you think. Let me know what you think of the movie. You think it's a great watch or not? I haven't checked it out yet. I might look at it today or tonight. But so far it seems like dark matter are the strings that connect the universes together and keep everything together. But they're like they say, they're invisible. You can't see them, light doesn't emit from them, but it holds everything together, I guess, in this universe.
Astronomers have just discovered a dark galaxy, one that is primarily made of dark matter. These types of galaxies are extremely dim, some outputting little to no visible light, and they are made up of around 90% dark matter. But if these types of galaxies don't emit visible light, how exactly did astronomers detect it? Well, these dark galaxies are predicted to contain large amounts of neutral hydrogen gas. Astronomers actually found the first dark galaxy completely by accident. Astronomers were surveying the sky for these hydrogen gas clouds and came across an isolated cloud that had a more disk-like shape, inadvertently discovering a dark galaxy. The most recent one discovered just this week, dubbed the New Galaxy, is thought to be around 10 billion years old. The formation of these galaxies with extremely low counts of stars in the thousands as opposed to the billions of stars in a typical galaxy is still largely unknown. Perhaps most of the stars have long died out, and this is just a glimpse of the fate of most galaxies. As more develops on this discovery, I'll be sure to update you.
Could that be a dark hole galaxy or what, man? I mean, I don't know nothing about outer space, so I may be wrong, but it's just a theory and a question.
When you say dark matter, what is it based on?
I'd like to just call it Fred for now.
Okay, let's call it Fred.
It's 6 times the gravity of stuff that's ordinary matter. We don't know the source, we don't know the origin. Is it a parallel universe? We don't know.
And how are we measuring it?
By its effect on the motions of objects.
Why are they calling it dark matter?
They shouldn't, in my opinion. They should call it dark gravity, because that's literally what it is.
So it's gravity that cannot be measured, or gravity that's
it's
not
gravity
completely understood.
It's not understood, correct. So it's mysterious gravity,
or it
dark
can't
gravity.
Be completely measured.
No, we measure it.
But you can't narrow down what the
measure
root of
its
it
gravity
is.
Precisely.
Okay, so you measure it, but you can't
so my
determine the origin?
We don't know what it is. My point is, because someone called it dark matter, it has swayed everybody into thinking that it is matter of some kind.
Oh, Neil, you don't know what you're talking about? No, I'm just playing. Yeah.
For the first time, there is indirect evidence that large amounts of invisible dark matter may surround black holes. Dark matter is an elusive substance that makes up about 85% of all matter in the universe. Unlike the matter that makes up stars, planets, and everything else we can see, dark matter doesn't interact with light and can't be seen. However, it does interact gravitationally, allowing researchers to infer its presence by looking at its gravitational effects on ordinary matter proxies.
There might be a shadow universe existing around us. It sounds like clickbait, but this is serious particle physics. Dark matter is one of the most serious problems in fundamental physics right now. There seems to be more gravity than there should be for the amount of stuff that we see. So where is all this extra gravity coming from? Well, before everybody in the comments screams about how dark matter is made up and we just need to change how gravity works, go watch the video tagged in the description. One possible answer, which is gaining more support in recent years, is the existence of a dark sector of particle physics. The idea is that in addition to our normal standard model of particle physics, with quarks and electrons and photons, there are other particles complete with their own forces that just don't interact with our particles. Then, one of the only signatures that such a family of particles would have is their gravitational interaction with our world. But there is one possible exception, the dark photon. One of the ways we understand particle physics is via so-called symmetry groups. These are basically mathematical descriptions of the kind of forces that can exist at the fundamental quantum scale. Now, the simplest symmetry group is the one that gives rise to electromagnetism and hence the photon. So the simplest model of a dark sector might be reasonably assumed to also have such a symmetry group, a kind of mirror to our electromagnetism. If so, there could also exist a dark photon. And the behavior of such a dark photon is interesting. If it were massless, like our photon is, dark matter may not behave as we expect it to, because dark matter doesn't seem to collide like regular matter does. On the other hand, if the dark photon had mass, then that opens up a lot more possibilities, including spontaneously transforming into our photon. As an interesting aside, there could be other dark forces, but those can't mix with standard model force carriers. And what's nice about the dark photon hypothesis compared with other dark matter models is that, regardless of the model of dark photon, it really only has a few free parameters. And that means that you can't keep tweaking the model to make it fit the data like you can for supersymmetric models or WIMP models. It's either there or it's not. The best part is, we're closing in on the ability to either detect dark matter in this paradigm or rule it out, and that's exciting.
It's interesting take on that, my fella. Y'all go follow him on TikTok, showing some love.
Every single star and planet and nebula and galaxy and everything we could possibly see makes up only 5% of the entire universe.
All of that is what we'd call ordinary matter, normal stuff that's made of atoms. But the vast majority of stuff in the universe isn't.
Something entirely invisible and untouchable is what holds galaxies together. It's what shaped the universe.
We call it dark matter, and there's at least 5 times as much of it as there is ordinary matter. Yet despite its overwhelming abundance, we've never detected it. The dominant kind of matter in the cosmos is a mystery.
Whatever dark matter is made of, it doesn't seem to interact electromagnetically at all. It doesn't absorb, emit, or reflect light. We can't see anything.
And because the act of touching something is due to electromagnetic repulsion, dark matter can't be touched. It passes right through everything it comes into contact with.
It does, however, interact gravitationally. It has mass. We know dark matter exists because we can see its gravitational influence all over the place.
Such as gravitational lensing taking place where there's no visible source, or within galaxy clusters where members are moving in ways only explainable if far more mass is present in those clusters than can be seen.
Or the observation that many galaxies rotate so fast that they should be flying apart if you only accounted for the gravity from the stuff that we can see. Very clearly, there's more to this universe than the stuff that we can see. A lot more, we just don't know what it is yet.
To the person who discovered dark matter, quite literally the biggest discovery ever made, happy birthday, Vera Rubin.
Happy birthday, Dr. Rubin. We're still trying to figure this out.
Still trending.
Hey, Alexandra?
What's up, Evan?
Since there's 5 times more dark matter than ordinary matter, shouldn't that make dark matter the ordinary matter?
I don't know. Let me know what you think about that last question there down below in the comment section.
This star is orbiting nothing. Well, kinda. Astronomers had previously thought that this star was orbiting a black hole, but now some astronomers believe it might actually be orbiting a never-before-seen type of star completely made out of dark matter. Dark matter is this invisible form of matter that makes up most of the matter inside galaxies. We still have no way to detect dark matter itself, but some theoretical modeling would allow for dark matter particles to clump together, forming a dark matter star. These stars would be entirely invisible, making them really hard to find. But this could be our best shot. The research is in its early stages, but I will update you as soon as we know more.
Crazy.
When astronauts go to space, are they in dark matter? I think that your question is coming from the fact that when you go out into space, you're like no longer where light is and things are dark. And so you have to understand what is meant by dark matter, which is a little bit confusing because the word dark is in the name. My favorite analogy is you're looking out the window and you see a tree and the branches are waving in the wind. And you know it's the wind, right? But you don't actually see the wind. You see the effects of the wind. You see the branch moving and you infer that something is exerting a force and that thing is the atmosphere blowing on it. It's the wind. And that is basically what we know about dark matter. We see the effects of some invisible matter. We look at a galaxy and we see how much mass is there, how much material, how much normal matter is there. But the gravitational effects that we see far exceed the amount of visible matter, visible material. So we infer that there is some dark matter there, some matter that we can't see. It's not explicitly about light, although it doesn't interact with light, right? So it's like it's dark to us. But just because you see black space doesn't mean that that's dark matter. We've never been able to like isolate a particle. Nobody knows what it is. There are theories, but we don't know what it is yet. So, an astronaut in low Earth orbit would conceivably be encountering the same amount of dark matter that we do here on the surface of the Earth. It's really not that far away. And I don't think that an astronaut would be like running into more dark matter than we do. If they're running into it in low Earth orbit, I'm pretty sure that it's all around us as well, but we don't know because we haven't been able to like figure out exactly what it is. Does that make sense? But no, just the fact that they're out in darkness does not mean that they are in or moving through dark matter per se. Does that make sense?
Man, I tell you what, man, I'm learning a lot about some dark matter today. A lot of things that I did not know about dark matter that I used to get twisted up with antimatter. But man, I'm telling you, I can tell you one thing, man. I'm telling you, this video is helping me out a lot. It's very informative.
Astronomers have found new evidence against the standard model of cosmology. They have discovered a theory that could replace dark matter and ultimately solve one of the biggest mysteries in astronomy. The new theory is called AQUAL and implies that dark matter may not exist at all. The researchers tweaked Newtonian gravity to fit the observations of galaxy rotation curves. Besides correcting a possible 90-year-old mistake, their results may open new windows to the fundamental understanding of gravity itself. But what happened 90 years ago that changed the course of cosmology? Why are physicists developing an alternative theory of gravity? Finally, and most importantly, how can the new idea lead us to a better understanding of the universe? Dark matter is one of the most important entities in the standard model of cosmology. It is a hypothetical form of matter believed to make up 27% of the observable universe. The problem is that dark matter does not interact with electromagnetic radiation, making it difficult to detect directly. Instead, its existence is inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Even the standard model of particle physics doesn't contain any elementary particle representing dark matter. Although scientists are pretty confident that dark matter exists, they are still trying to understand its properties and behavior. Their goal is to develop a definitive theory that explains its nature. To understand AQUAL, it's important to learn how dark matter even came into the picture. It was in 1933 when Swiss astronomer Fritz Zwicky noticed something was missing in the universe. He studied galaxy clusters and concluded that the observed mass of matter was not accounting for the total mass of the galaxy cluster, found based on the motion of the galaxies held together by the gravitational force. He discovered this discrepancy in the Coma cluster. Zwicky first calculated the mass of the Coma cluster by studying the galaxies at its edge. He then compared it with the mass based on the brightness and the number of galaxies in the cluster. The two values didn't match. As a result, he obtained evidence for an unseen type of matter, which he called dark matter. Supporting his study came American astronomer Vera Rubin's analysis of galaxy rotation curves. A galaxy rotation curve.
Well, y'all, let me know what you think about dark matter so far. Man, I'll tell you one thing, it's been a good one and I really enjoyed y'all's time. Ooh, man, I ain't gonna lie, I learned a lot of stuff about dark matter that I didn't know, and I hope you did too. Let me know what y'all think about that clip down below. And y'all have a good evening, a good night, a good morning whenever y'all watching this video. If y'all watching this video on Thursday, well, y'all a day late. This video was recorded on Wednesday night, you know, but it's all good, y'all. I hope y'all enjoyed the show. It's your main man Koozie. I'm out. Y'all take it easy.